All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for this factoring, you're going to start by factoring out a 4, and you're going to have x squared minus 8x plus 16. And then that'll factor as x minus 4 times x minus 4, which you can write as 4 times x minus 4 squared. And so that would be your answer for the factoring. Now for the math knowledge question, you are going to want to distribute the negative. So you're going to have 4x squared minus 3x plus 7 minus a negative 1 is plus 1 minus 5x minus 2x squared. So now we can combine our like terms. We have 4x squared and negative 2x squared. Well, that's 2x squared. So that means we can go ahead and eliminate d and e. And then we have negative 3x and minus 5x. Well, that's negative 8x. Well, the only one that has that is a. And if we check, 7 plus 1 is 8. So a would be your answer there. Okay? Now for lesson 85, we're looking at advanced trig equations, and then we're going to also look at clock problems. Okay, so hopefully you'll understand the advanced trig equations and the clock problems after this lesson. So we want to solve this. 3 tangent squared of theta minus 7 secant of theta minus 5. So if you notice, we have a tangent squared and a secant. Well, we're not going to be able to factor that. What we need to do, though, is figure out how to write tangent squared in terms of secant. And that's going to be using one of your Pythagorean identities. So I'm going to start with this one, because that's the one that I told you had to learn. Now, some of you may know the one that deals with tangent squared and secant. That's going to be the one that you divide by cosine squared. And so sine squared over cosine squared is tangent squared plus 1 equals secant squared. So tangent squared of theta is secant squared minus 1. And so instead of tangent, we're going to replace it with secant squared theta minus 1. Then we have 7 secant of theta minus 5. Now if we distribute, we have 3 secant squared theta minus 3, and then 7 secant of theta minus 5. Now that we have it with secant squared and secant, we want to set it equal to 0 so we can factor. So we have 3 secant squared theta minus 7 secant of theta, and then plus 2 equals 0. Now we want to factor this. This is in the very same concept as 3x squared minus 7x plus 2 equals 0. So you're going to do a remove, replace, reduce, just like you would do for this one. So we're going to have 3 secant of theta, because that's what our x is, 3 secant of theta. And then we want to know what multiplies to give us a 6 and adds to give us a negative 7. Well, that would be negative 6 and negative 1. The first one will reduce, and we'll have secant of theta minus 2, and then 3 secant of theta minus 1. So that means that we have secant equals 2, and secant equals 1 over 3. Okay? Now, I don't off the top of my head know what my secant values are, but I know my cosines, or you should anyway. I told you you had to learn them back at the beginning of the year. The reciprocal of secant is cosine, so the reciprocal of 2 is 1/2. The reciprocal of secant again is cosine, and the reciprocal of 1/3 is 3. Now, where does cosine equal 1/2? Well, it equals 1/2 at a 60-degree angle and a 300-degree angle. So those are 2 answers. Where does cosine equal 3? It never does. So we ignore that one. Doesn't mean we did it wrong. It just means that we have no answers from that one. So we can throw it out. So our only 2 answers here are going to be 60 degrees and 300 degrees. Okay, let's look at the next one. We have 2 sine squared x plus 3 cosine of x. We're going to want to replace. Instead of sine squared, we're going to want to say 1 minus cosine squared. And so now we're going to distribute, and we're going to have 2 minus 2 cosine squared of x equals 3 plus 3 cosine of x. On this one, I'm going to move everything to the right side because I want my cosine squared to be positive. So 0 equals 2 cosine squared of x plus 3 cosine of x, and then minus 1. No, plus 1. All right, so again, this is going to factor in the same way that 2x squared plus 3x plus 1 would factor. So we're going to have 2 cosine of x, 2 times 1 is 2, and we're looking for what multiplies to give us 2 and adds to give us 3. So that's going to be 2 and 1. The first set will reduce. We'll have cosine of x plus 1, and then 2 cosine of x plus 1. So now, cosine of x would equal negative 1, and cosine of x would equal negative 1 over 2. So cosine of x equals negative 1. That's one of your quadrantal angles. Does anybody remember which one it is? It's 180 degrees. Over on the left here. That's where our x value is a negative 1. And then cosine of x equals negative 1/2. That's a 60-degree angle, but it's in the second and the third quadrant. So that would be 120 and 240. And so on this one, you actually have 3 answers. 180, 120, and 240. Okay? Now let's look at another example. We again have tangent squared and a secant. So just like we did on the first one, we're going to replace that tangent squared. And it's going to be replaced with secant squared minus 1. So we're going to have 2 secant squared minus 2 equals secant theta minus 1. So I'm going to move everything to the left side. 2 secant squared minus secant of theta, and then minus 1 equals 0. And again, this is going to factor the same way that 2x squared minus x minus 1 would factor. So we're going to have 2 secant of theta, 2 secant of theta. We're looking for what will multiply to give us a negative 2 and add to give us a negative 1. So negative 2 and a positive 1. So this first one will reduce. And the second one won't. So now we solve them. Secant of theta equals 1, or secant of theta equals negative 1 over 2. Well, the reciprocal of secant is cosine. The reciprocal of 1 is 1. The reciprocal of secant is cosine, and the reciprocal of negative 1/2 is negative 2. Cosine never equals negative 2, so we can throw that one out. And the only place that it equals a 1 is going to be at 0 degrees. And so that would be our answer here. Just 0 degrees. That's the only one that would work. Okay, so now we're going to move on to clock problems. These are the formulas that you're going to use for your clock problems. When we have a clock, we've got a little hand and a big hand. Your little hand and your big hand. Okay? All right, so your little hand is your hour hand because it's the little one, it's the small one, okay? And then the big hand is your minute hand because it's the big one. And we're not actually going to use the second hand. We're only looking at the little hand, the hour hand, and the big hand, the minute hand, okay? So, there are 60 minutes in 1 hour, right? The rate of the big hand is 1, and what that means, it goes 1 space per minute. And there are 60 spaces on the clock. And so it takes 5 minutes to go here, from this one to that one. Now the rate of the little hand, it is a 1 over 12, if you see here. Because how long does it take to get from this 12 to the 1? It takes a whole hour, which is 60 minutes, to move 5 spaces. So it moves 5 spaces in 60 minutes. That's where the 1/12 comes from. 5/60 reduces to 1/12. Okay, so those are the rates. Now the time. The time is the same for the little hand and the big hand because the times are all being used on the same clock. We can't have the minute hand moving without the hour hand moving. If I move the minute hand, watch what happens to the hour hand. You see how it moves too? As the minute hand moves, the hour hand has to move, okay? So the time on those is the exact same. Now, for the little hand, it's going to move a certain number of spaces. And we don't know how far, but we know that it moves a certain number of spaces. And then the big hand moves the same number of spaces plus a little t, and that depends on the time that they give you in the problem, okay? So we are going to do a little bit of substitution here to show you how you can actually simplify your formulas. The times of the little hand and the big hand are the same, so I'm going to actually make those just equal a big T, okay? Now the rate of the little hand is 1/12, so this would be 1/12 big T equals the number of spaces that it moved. And then the rate of the big hand is 1, so it's just going to be T equals the number of spaces plus the time that the problem gives you, okay? These two formulas are really what you need to learn. 1/12 T equals S, and T plus S equals little t, okay? So we're going to look at the next example, or the first example of this one. It says the hands of a clock point in the same direction. In how many minutes will they point in opposite directions? So on this one, you would think if I started it at noon, how long will it take before the hands point in opposite directions? Well, that'd just be moving the minute hand down here, and that'd be 30 minutes. But look, what happened when I moved this minute hand from here? What happened to the hour hand? Do you see how it moved a little bit too? And so we've got to keep moving, and now they line up. And so do you see how that was a little bit more than 30 minutes? And that's what we're trying to figure out. Exactly how many minutes will it be before they point in opposite directions? So here's how you use those formulas. You're going to have 1/12 big T equals the number of spaces. And then you're going to have T equals spaces plus time. And so we're looking to figure out what that time would be. So what we're going to need to replace, instead of this little t here, it's going to be 30, because that's how many minutes it would take if the little hand, the hour hand, had not moved. Okay, and so we're going to have to add in the number of spaces that the hour hand moved to find out the actual total time. So S equals 1/12 T, so we can replace that in our second equation. And then if we say T minus 1/12 T, we would get 11/12 T. And then we can multiply by 12 over 11. And so I get 360 over 11, which we want to change that as into a mixed number. And so that would be 32 and 8/11 of a minute. And so that would be your time. You don't want to give these as decimal, you do want to give them as a fraction. And you want to write it not as an improper fraction, but as a mixed number. So that's how many minutes it'll take before they point in opposite directions. Okay? Now, again, this is assuming that the hour hand had not moved. The little hand did not move. That's where you find that number. Okay? And then, once you know how far it would be if it had not moved, you apply it to those two formulas. So let's look at another example. So it says that it is 3 o'clock. So I'm going to make it 3 o'clock on my clock. So now it's 3 o'clock. In how many minutes will the two hands of the clock point in the same direction? Well, my minute hand is going to keep moving. And if the hour hand didn't move, it would only take 15 minutes before the two would be pointing in the same direction. Okay, so we're going to use our formula. We're going to have 1 over 12 t equals our spaces, and then t equals the spaces plus 15, because it was going to be 15 minutes, but that little hour hand just kept on moving. So we'll have t equals 1/12 t plus 15. T minus 1/12 t is 11 over 12 t equals 15. So multiply by 12 over 11. And so your time, 12 times 15 is 180 over 11. And so if you write that as a mixed number, you're going to have 16 and 4/11 of a minute. And so that would be how long it would take before it would be where you have your hands pointing in the same direction. So hopefully that helps you a little bit with the trig equations and also with the clock problems. Your homework tonight is 1 through 30, so you need to make sure you do that so that we can go over any questions that you have tomorrow.